In the case of Carnot machine, show that VB divided by VA equals to VC divided by VD. You know, in the case of Carnot machine, if you put PV diagram, we have A, B with T constant, and AB we have Q hat, and we have TA equals to TB equals to T high. Between B and C we have adiabatic process Q equals to O, and between C and D we have Q cold out of the system is negative, and TC equals to TD is T cold. And between D and A, we can say like this, we have an adiabatic process Q equals to O. Okay, first of all, in general, if you are solving a problem and you have a Carnot machine, you can apply the relation between VB, VA, VC, VD, where VB divided by VA equals to VC divided by VD. Okay, you can use them directly. But here I ask you to find this relation. You have to find it. Or maybe I ask you to find the efficiency in the case of Carnot machine at E equals to 1 minus T cold divided by T hat. Maybe I will ask you directly to find the relation of E Carnot. Okay, let's start by part 1. First of all, to find VB divided by VA equals to VC divided by VD, you can use the relation in the case of adiabatic process between B and C, or between D and A. You know, we have adiabatic process and TV gamma minus 1 is constant. Okay, you have TV gamma minus 1 is constant. You can say in the case of BC, we can say T B VB gamma minus 1 equals to T C VC gamma minus 1. And in the case of DA process, TD, you can, okay, you can say TD, we can say TD VD gamma minus 1 equals to TA VA gamma minus 1, or we can write it directly TA VA gamma minus 1 equals to TD VD gamma minus 1. Okay, we can divide each one here. You know, TA equals to TB and TC equals to TD. You know, TA equals to TB equals to T high, and TC equals to TD equals to T cold. Between A and B, C and D, we have isothermal processes, and between B and C, D and A, we have adiabatic. We have adiabatic. Okay, so here we have T, B, and TA. We can eliminate these two values, these two terms, and also see TC and TD. Now we get finally from this one VB divided by VA gamma minus 1 equals to VC divided by VD gamma minus 1. We can eliminate this one and this one to get finally VB divided by VA equals to VC divided by VD. I repeat, you can use this relation between the volume of each state directly without calculation if you are solving a problem with a Carnot machine. Okay, now I ask you to find this value. It's important to find the relation between the volume of each state. Okay, so part 1, we found this relation. Okay, in part B, we have to prove that the efficiency E Carnot equals to 1 minus T cold divided by T hat. In part 1, we used the transformations B, C, and dA to find VB divided by VA equals to VC divided by VD. Now in part B, we have to use AB and CD. You know, in general, E for any machine equals to 1 minus Q cold divided by Q hat. Here, I don't know. We cannot say Q cold is QCD and Q hat is QAB directly. You have to prove that QAB is positive, it's Q hat, and QCD is negative, it's Q cold. Okay? So we have to find Q cold and Q hat. You know, in the case of T constant, in the case of isothermal process, we have omega AB equals to QAB. I don't know, I don't need to repeat the how can we write this one. You know, in the case of T constant, delta E equals to O, delta E equals to Q minus omega. So Q equals to omega. And the same for CD. Delta E CD equals to O. So omega CD equals to Q CD. And omega, the work done in the case of T constant equals to N R T, TAB is T hat, ln V final divided by V initial. Okay, you have to know this relation directly without proof, without calculation. And you know omega CD equals to Q CD equals to NR T cold ln V final divided by V initial. Okay? Okay, first one. As we have VB is greater than VA, so ln VB divided by VA is positive. So as VB is greater than VA, we can say ln VB divided by VA is positive. So N is positive, R is positive, T is positive, we can say omega or QAB is positive. Now you can say that QAB is Q hat. If you have one is hot, the other will be cold. Okay, we can say here, so QCD is Q cold. Okay, if you want to prove QCD, you know why VD is less than VC, so ln VD divided by VC is negative, and we can say QCD is negative. It's Q cold. So now we found Q cold and Q hot. We can substitute each value in this relation. We can put here 1 minus the absolute value of Q cold, which is equal to N R T cold ln V D divided by VC. Okay, divided by Q hat, which is equal to N R T hat ln VB divided by VA. We can eliminate N, R, R. So 1 minus ln absolute value of ln VD divided by VC and ln VB VA. Okay, you know ln we calculated before here, VB divided by VA equals to VC divided by VD, or we can say ln to this side equals to ln to this side. You have to know this relation. Okay, we come back to this one. To have ln VB divided by VA, it's okay, we have it here, but we don't have VC divided by VD. We have to inverse ln VD divided by VC. You know, this one, ln VD divided by VC equals to minus ln VC divided by VD. Okay, to get the same form of this one. So we can say here E equals to 1 minus ln VC divided by VD and ln VB divided by VA. Ln of negative value is positive, okay? Ln of negative, here we have a negative, so we can eliminate the negative to get a positive value. So as we have here, ln VB divided by VA is equal to ln VC divided by VD. And the absolute of, don't forget here we have TC and TH. Okay, T cold and T hot. Okay, I repeat, we can eliminate this one and this one, and the absolute value of the negative will be positive. So E equals to 1 minus T cold divided by T hot. We found it.